Hello everyone, Siddharth this side, and today we will be solving another question on Geek for Geeks, which is three-way partitioning. So what we have to do in this problem is that we have given an array and we have given a range. So what we have to do, we have to arrange this array according to this given range. All the element less than the lower range should be before that, and all the element between this range should be between the array, and all the element greater than this 2 should be on the right side of 2. So this is what we have to do in this problem. So let's start discussing how we can solve this problem in a linear traversal. So this is our array 1 2 3 3 4. So 1 2 3 3 4. So as we have to swap the numbers, guys, for arranging the elements. So the first approach that should come to into our mind should be the two pointer approach. We will start from 1 and 4, and we will keep track. We will move into our array using any index, suppose I, and we will compare from the start if this element is less than from the, suppose a comma b is a range. So if this element is less than a, if 1 is less than a, so what we will do, we will swap this element with a starting index. As it is smaller than this, so it should come in the start of the array. So this is our first condition. Second one will going to be, if we encounter any element which is greater than this b, suppose 2 is greater than b, then we will swap this 2 and b using our AND index. We will swap 2 and b with our AND index. Sorry, not b, it should be element at AND index. So array AND. So, but in this case, we will not update our ith index because we have to check again for this element. Suppose here it is, suppose this element is greater than 3. Suppose b is 5, and here the element of the array is 6. So we will swap this element. We will swap 6 and 4. So 4 will come here. But if we update our I here, then we will miss this element because we have to check this element again if this element belongs to the right side of the partition or not. What if this element is less than here? Then we have to update that. What if it is greater than this element, last element? Then we have to swap it with the end. So this is the concept we will be using. And if we will not encounter any of these two conditions, then we will simply update our I, as we have found the element which is at the right position. So this is the concept, guys, that we will be using. Now let's move on to the coding part. So let me jump on the screen. Okay. So guys, in the start, what we will do, we will create two pointers. So int start pointing to 0, comma end is pointing to our last element, array of length -1, and our ith index is pointing to 0 in the start. Now what we will do, now we will start traversing into our array. So while I is less than or equals to n, now we have to check for two conditions. If the element at ith index is less than a, so if it is less than a, should be in the start of the array. So we will swap element at ith index and element at start index. Now we have to update our pointer as well. So start plus plus and I plus plus. And in this case, we are updating I because this condition this condition ensures that the element that we will be swapping is in the right position. Now the another condition will going to be if the element at ith index is greater than our element b, then we will swap the element at ith index and the element at and I index. So after swapping this, what we have to do, we have to update our last pointer, ending pointer, and we don't have to update I here as I have told earlier, because we can't say that the element that we swap from the end is in the right position or not, in the right partition or not. And in the last condition, we simply have to update our I. And now let's write the swap function, guys. Private void swap. So we will take an array. We will take two index. Now we will create a temp variable in the store our first element in it. Now we will assign the second element to our first element. Now in the last, we will assign temp value to our second element. Now let's try to submit this problem. I think the code is looking fine. So, okay, array is equal to okay. We missed the semicolon here. Okay, let's try to submit this problem. So all the test cases have been processed, guys. See you in the next video. Bye.